So, good day everyone. Today we'll be discussing our practical exam. So, we are given a problem statement. You design a circuit of a decade counter that will count from 0 to 9 only. You will only be using the following: A. A button. Only one button will be used to trigger the counting. B. Flip-flop IC to be used as counting circuit with 4 bits binary output. C. ICs for decoding the binary output of flip-flops to decimal output. And D. 7 segment display to display the output from 0 to 9. So here's our block diagram, and first in doing it, we will be solving its truth table, its K-map, and its Boolean equation for us to get our 4-bit binary decoder circuit. So let's head on to creating its schematic. So for this circuit, you will be needing this following ICs. So the 7 segment, for me, common cathode, 74LS73 or JK flip-flop IC, 3 input NAND gate, 2 input OR gate, 4 input OR gate, 3 input AND gate, 3 input OR gate, 2 input AND gate, push button, resistor, and voltage source. So let us now create our circuit. is our finished circuit. So first off, this is our flip-flop circuit, which is composed of the 7473 JK flip-flop IC. So as you can see, our button is connected to the first clock input of the first JK IC, and then its output Q is connected to the next clock input of the next JKIC, and so on. And the JK is set to high, so therefore our Q will only toggle if the clock input is from high to low. So as you can see, our button is now on high, and once we if we first push our button, QA will toggle because our input is high to low clock input. Therefore it will toggle its state, and this will become 1. So QB remains and the rest, because the previous IC is not high to low transition. And then on the second button, our QA will toggle once again because its input is a high to low input, and QB will also toggle because its input from the previous IC is a high to low input, clock input, and it goes on for all of these IC inputs until it reaches a value of 10, as it is connected that way. Once it reaches the Boolean value of 10, it will toggle this NAND gate to clear all the memory and reset it back to 0. And now our outputs are connected in reverse. So from the least significant variable will be your rightmost value in your Boolean value, and so on and so forth. And next is our decoder circuit, which we got from solving its truth table, K-map, and its Boolean equation. So when we solve for its decoder, we will get this schematic diagram. And so let us test our circuit. It should have an output of 0 to 9 and reset after 9. So here it goes. This for 1, 2, 3, 4, 5, 6, 7, 8, and 9. So our outputs are correct because the 7 segment shows numbers 0 to 9. So when we click this button, it should reset back to 0. And so it is. So that is how JK flip-flop works, and this is my final schematic diagram. Thank you and have a good day.